In this video, I will be explaining to you the chosen mechanism for our T1b video. This is our first mechanism prototype. How it works is that it uses a seesaw-like mechanism, where a force is applied onto one of the block, pushing it into a wall. When that happens, the block beside it will extend down. This allows Ophelia to grab onto the blocks, pulling herself down to the platform below. How the seesaw mechanism works is with a pivot in the middle that holds the entire mechanism together and a plate that connects both blocks together to create the seesaw-like effect when force is applied. A flaw in the design was that the entire mechanism is protruding out of the wall, as it was advised for the entire mechanism to be within the wall. Hence, this brings us to prototype 2. For prototype 2, we tried to squeeze the entire seesaw mechanism to fit into the wall so that the mechanism is hidden. We had to scale the mechanism to a smaller scale so that it is hidden within the wall. By doing so, the mechanism is still too bulky to be hidden within the wall, which might affect the functionality of the mechanism. Hence, we explored other mechanisms in the next few prototypes. The mechanism for prototype 3 is similar to a drawer mechanism. As Ophelia climbs down the wall, she has to grab onto the groove, pulling out the block like a drawer. The grooves also act as a grip for Ophelia to hold onto as she climbs down. To avoid Ophelia from pulling out the blocks too much, there is an extension at the back of the block that will clash with the exterior wall, preventing Ophelia from pulling out the block and locking them in place. The mechanism and design work, but we decided to further explore other mechanisms in the later prototypes. We decided to redefine the seesaw mechanism in this prototype. Thus, for this prototype, we referred to prototypes 1 and 2, but we shortened the thickness of the blocks. This allows more space within the wall for the mechanism. How the mechanism works is that only one side of the block will be able to protrude out when force is applied. With only one side of the block protruding out, Ophelia can easily grab onto the block, as there will be a gap for her hands to grip onto. The downside of this design is that one of the block will never be flushed along the wall, as in this mechanism, one of the plate is longer than the other, connecting to the panel. This allows the pushing and extruding of the block when force is applied. For this prototype, the mechanism is flushed along the wall, as the blocks is connected to the plate of the seesaw mechanism. However, after looking at this prototype for a while, we realized that as Ophelia grabbed onto the flap as she climbs down, it might not be able to hold onto her weight, as only one side of the panel is connected to the wall, supporting her weight. Therefore, this brings us to our final design. For our final design, the entire mechanism is integrated within the wall. Each of the blocks has a groove for her to hold onto as she climbs down. Within the wall, it is the seesaw mechanism that activates as a force is applied onto one of the blocks. As Ophelia climbs down the wall, she sees the blocks on the wall. This would signal her to push in the blocks with her leg, creating platforms for her feet and hands when the other blocks extrude out. The blocks are supported by the plates within the wall, part of the seesaw mechanism. Hence, as she figures out the mechanism, she will be able to easily navigate along the wall. This is our chosen mechanism.